Molecular geometry, VSEPR theory, 5 electron domain molecules. In this tutorial, we will be looking at 5 electron domain molecules, trigonal bipyramidal geometry, specifically examples of phosphorus pentachloride, sulfur tetrafluoride, chlorine trifluoride, and a xenon difluoride example. Let's look at our first example, phosphorus pentachloride, PCl5. Phosphorus pentachloride has 5 electron domains. In other words, 5 single PCl bonds around the central phosphorus atom. So 1, 2, 3, 4, 5. And in this particular model, the lines that are straight up and down and over to the side are directly on the page, while this representation is supposed to convey the idea of the Cl going back into the page, and this representation is the Cl coming out of the page. So a little bit more of an example of how to make a Lewis structure more three-dimensional. The bond angles in the axial or vertical plane are 90-degree bond angles. So we're talking about bond angles between here and here, and even if this one was coming out of the page, here and here, and of course in the back as well. But that's what we're talking about when we talk about 90-degree bond angles. The bond angles in the equatorial or horizontal plane are 120-degree bond angles. So that is if we rotated this, so our chlorines that are straight up and down are now going back into the page and out of the page. The bond angles here, here, and here are all 120 degrees. So that's something to keep in mind when you're thinking about trigonal bipyramidal geometries. Note that there's no non-bonding electron pairs on the central phosphorus molecule. So we do not see any lone pairs here or represented in these molecules. So the electron geometry is trigonal bipyramidal, and the molecular geometry is trigonal bipyramidal. And a reminder here, these will be exactly the same all the time if there are no lone pairs on that central atom. Let's look at our next example, sulfur tetrafluoride, SF4. Sulfur tetrafluoride has 5 electron domains. 4 of the electron domains are single bonds between the sulfur and the terminal fluorine atoms. So 1, 2, 3, 4. 1 electron domain is a non-bonding electron pair on the central sulfur atom. So this one lone pair that's located here and is represented as this lone pair in this model. In both equatorial and axial planes, the non-bonding electron pair on the sulfur atom has 90-degree bond angles with the 2 SF bonds and the 120-degree bond angles with the other 2 SF bonds. So we can see that we have the 90-degree bond angle here and here, and then the 120-degree bond angle here. And we can see the compression that occurs when this lone pair appears on this central sulfur atom. The electron geometry is trigonal bipyramidal, and the molecular geometry is called seesaw. Let's look at our next example, chlorine trifluoride, ClF3. Chlorine trifluoride has 5 electron domains. 3 of the electron domains are single bonds between the chlorine and the terminal fluorine atoms. So 1, 2, 3. 2 electron domains are non-bonding electron pairs on the central chlorine atom. So 1 non-bonding pair, the second non-bonding pair. There are 90-degree bond angles between each chlorine to fluorine bond. The electron geometry is trigonal bipyramidal, and the molecular geometry is T-shaped. And we can see that T right here in our Lewis structure and in our VSEPR structure. Our last example is xenon difluoride, XeF2. Xenon difluoride has 5 electron domains. 2 of the electron domains are single bonds between the xenon and the terminal fluorine atoms. 3 electron domains are non-bonding electron pairs on the central xenon atom. So 1, 2 for our single bonds, and then 1, 2, 3 for our non-bonding electron pairs. There are 180-degree bond angles between each xenon to fluorine bond. The 3 non-bonding electron pairs are 120 degrees apart. The electron geometry is trigonal bipyramidal, and the molecular geometry is linear. So what did you learn? We looked at the 5 electron domain molecules with a trigonal bipyramidal geometry: phosphorus pentachloride, sulfur tetrafluoride, chlorine trifluoride, and xenon difluoride. Need more help? Feel free to contact me. Have a great day.